In this video, I'm going to show you how to conduct the one-way ANOVA or one-way between subjects ANOVA in Jamovi. The one just refers to one independent variable, and with the ANOVA, that's going to be a categorical variable with at least usually 3 levels. You can technically do it for 2 different groups, but in that case, you could just do a t-test. So I don't do one-way ANOVA unless I have a categorical variable with 3 or more levels, and then your dependent variable is continuous. So we're looking at the mean difference of a dependent variable across different groups. So in this example, the research question, is there a difference in academic self-efficacy between students who react differently to pop quizzes? So panic mode, Zen acceptance, or depends on the situation are our categories, and we're going to compare academic self-efficacy across those different categories. So I'm going to go ahead and pull up Jamovi and run through how to conduct this test. Here I am in Jamovi, and you can see this is actually the first variable that we're going to use is this pop reaction. So we have different ways that students react to pop quizzes, and these are categories. And then we're going to use the continuous variable, which is a total score on the academic self-efficacy scale. So this is, here we go. This is again a self-efficacy scale that's continuous. So we're looking at looking at the mean of academic self-efficacy across these different groups. When you go to ANOVA, you're going to notice there's a one-way ANOVA option. It just doesn't have the same options as the ANOVA, and so I use this second ANOVA option here. So when you're here, you can do this for 2-way ANOVA and 3-way ANOVA with multiple different variables as well. We're just using one for this example, but we're going to look at our pop reaction is our independent variable, and that's going to be our fixed factors. And then we're going to put our dependent variable, academic self-efficacy, where it says dependent variable. So you can see that Jamovi tells you what types of variables are appropriate there. So this academic self-efficacy has to be a continuous variable, which is what the little ruler refers to, or scale. And then your fixed factor could be nominal or ordinal. And so nominal is the little dots, just groups, categories that don't have natural ranking. And then ordinal would be groups that have natural ranking. So for this, I don't need to select this overall model test because it actually gives you that already, but I do want to select effect size. And so the eta squared, this fancy N looking thing, is the effect size for the effect of all independent variables on the dependent variable. So for this example, because we only have one independent variable, that's the only effect size that we would really need to talk about. You can also use omega squared, which is this one over here. It's a little more conservative, so you're less likely to overestimate the effect. But typically, I think partial eta squared is a little bit more common to see. The next step is that we would make some decisions on if a post hoc test is necessary. And so in this case, you only do a post hoc test if your overall model is significant. So this overall model, because our p-value here is greater than, it's not less than 0.05, we're going to fail to reject the null hypothesis. And in this case, the null hypothesis is about the omnibus test. That's what it's first starting with, is saying, okay, overall, are there significant differences in academic self-efficacy across these different groups? Because there is no overall difference, we can stop there. For the purpose of this video, I'm just going to show you that you can go to this post hoc tests right here, and you can move over pop reaction into the post hoc box. I'm using Tukey's, honestly, significant differences post hoc tests. You could use a different one if you prefer. And then this is Cohen's D for the effect size. So I can go ahead and add the effect size measure for each of these relationships. Now, again, I wouldn't do this normally if my p-value were so high, but just for the sake of this video, showing you what to do. You can also go to estimated marginal means. And so what this does is it gives you the mean of each of these groups, and that the marginal means, if we had 2 independent variables, we could talk about this a little bit differently, but basically this is just the mean for each group. So you can have a plot And again, you just have to drag your term over here, your independent variable. And so you can see that they've plotted them out here. And then you can also do tables, which can be helpful here. So you can see the mean for each of these groups and use that to talk about descriptive information. And then in the next video, I'm going to talk about running assumption checks. So that's what we're doing in class is kind of this basic one-way test. And then the next video, again, I'll talk about assumptions for this test.